Welcome to my video on solving addition and subtraction inequalities. So what is an inequality? An inequality is a mathematical sentence that contains one of the following symbols. We have greater than, less than, greater than or equal to, or less than or equal to. Okay, so my question is, now that we know what an inequality is, which of the following is an example of an inequality? So which one of these has one of those symbols? Good, the correct answer is B. So what is the keyword in question one? The keyword was inequality, and we should have probably done the keyword first. So sorry about that. Okay, number two, which of the following could be placed in the blank below to create an expression? So it says, what is the keyword? So what's the keyword in this question? Good, the keyword is expression, so write expression. Now, we know what an inequality is. We just reviewed that, so an expression can't be A or B. And we know that C is an equation, because anything with an equal sign is an equation, so it must be choice D, because if I put an addition sign, it's not an equation, it's not an inequality, but rather an expression. Okay, so graphing well, let's shift this down. Graphing inequalities. Less than or greater than does not include the number, so we use an open circle. So, and we'll see that below, and I'll explain that further. Less than or equal to or greater than equal does include the number, so we use a closed circle. So it says x is less than 2. So if I'm saying x is less than 2, I put an open circle, and that means 2 cannot be a solution. Okay, because it has to be less than 2, so it can't be equal to 2. So now we're going to shade to the left because we want less than. So we're going to, and you just color it in and shade this way. Okay, now look at the next one. The next one says 1 is less than or equal to x. So if I read it backwards, that means x is greater than or equal to 1. And the best way to graph is when the letter's on the left. It's much easier to read it because now I see x is greater than or equal to 1. So now I'm going to shade greater than or equal to 1. Now this time it can equal 1 because it's greater than or equal to. So I'm going to put a closed circle, and I'm going to shade to the right for greater than or equal to. So for shading purposes, okay, I want the variable on the left, so I need to read it backwards when the variable is not on the left, like this. So read it backwards, x is greater than or equal to 1. Okay, now turn the page. And here are steps for solving addition and subtraction one-step inequalities. So it says the steps are the same as solving one-step equations. So the first goal is to get the variable by itself. Perform the same operation, addition, subtraction, multiplication, or division on both sides of the inequality. To solve an inequality, we always think about doing the opposite or inverse. So put inverse in parentheses here. Whoops. That's inverse of what is given. So we have the golden rule of algebra. What we do to one side of the inequality, we must do to the other. So now let's look at some examples. This is solve and graph each inequality. So just like we did addition equations, we're going to draw our t. And the opposite of adding 2 is subtracting 2 from both sides. The 2's cancel. So x is less than -7. So what I want to do here is do an open circle, and we're going to shade to the left because we want less than -7. So we're going to shade this way. Now, I can check to see if it's correct. Now, first of all, I can check the number. If I plug in -7, what's -7 plus 2? -5. So, and this is -5 over here. So I know the number is correct. Now, if I want to see if my symbols go in the correct way, I can plug in a number less than -7. And that's -8, because remember, with inequalities, there's more than one answer. So let's use -8. What's -8 plus 2? -6. Is -6 less than -5? It is. So that means my solution is correct. So x is less than -7. Now, there's another way that I can write this, and I want you to write this down, okay? Or I could also write -7 is greater than x, because sometimes you might not see x is less than -7, and you've got to know that -7 is also greater than x, and that means the same thing. Okay, let's look at example number 2. Draw your t. And the opposite, or sorry, if I want to cancel out 7, I'm going to subtract 7 from both sides. The 7's cancel. Bring down your x. Bring down your symbol. So x is greater than or equal to 5 minus 7, -2. Now let's go ahead and write the other way, or -2 is less than or equal to x. Now, when you solve these on your own, okay, I don't need to see both every time, okay? I want to see the one, especially if we're graphing, I want to see it with the variable on the left. If we're not graphing, then that's up to you, how you want to present your answer. But when we're graphing, we want the variable on the left because now it's easy to shade. So x is greater than or equal to -2. So that means I'm going to do a closed circle on -2. And I'm going to shade greater than or equal to, which means I'm going to shade to the right. So greater than or equal to. Whoops. Okay, so turn the page. And we've got 4 more examples to look at. Now, number 3 says x minus 9 is less than -14. So I'm going to draw my t. And the opposite of adding 9, the opposite of subtracting 9 is adding 9. Got a little ahead of myself there. The 9's cancel. So x is less than -14 plus 9 is -5. So x is less than -5. Or we can also write -5 is greater than x. Those are 2 ways to write the same thing. Okay, now open or closed? Open around -5. And where am I going to shade for less than? To the left. All these numbers are less than -5. Okay, look at the next one. I have -14 is greater than x minus 9. So what I'm going to do first is draw my t. And the opposite of subtracting 9 is adding 9. Okay, the 9's cancel. -14 plus 9 is -5. Bring down your symbol is greater than x. Now, it's okay to leave your answer like this if that's the way it ends up. But since we're graphing here, we also want to write it the other way. So read it backwards. X is less than -5. Now, when the variable's on the left, we can just read it and shade that way. So x is less than -5, so open or closed? Open. And where are numbers less than negative 5. Good, to the left. And notice 3 and 4 are the exact same problem, only it's written differently. Here it says x minus 9 is less than negative 14. Here they read it backwards and rewrote it. Negative 14 is greater than x minus 9. So my point is, both of these are correct answers. Negative 5 is greater than x, or x is less than negative 5. Please know how to write both. Okay, I'm not going to write both anymore unless it's written backwards in the first place. So let's see what happens with 5 and 6. All right. So draw your t. And here's my variable. So I want to get rid of the 4 by subtracting 4. The 4's cancel. 12 minus 4 is 8. Is less than or equal to x. Now here I'm going to have to rewrite it because it's written backwards. So read it backwards. X is greater than or equal to 8. Okay. Box this in. And open or closed? Closed. And we are going to shade to the right because we want greater than or equal to. Okay, now I forgot to show you the checks for the other one. So since we haven't checked one in a while, let's check this one. So we got 8 for our number. So what's 4 plus 8? 12. So both sides are 12, okay? The number looks good. Now let's pick a number greater than, because we already know 8 works. So let's pick a number greater than 8. So let's say 9. What's 4 plus 9? 13. Is 12 less than or equal to 13? It sure is. So I know my number and my symbol are both going the correct way. Okay, our last example. Draw your t. And what's the opposite of, or sorry, I shouldn't say opposite here. How do I cancel out 7 negatives? 7 positives. Okay, the 7's cancel. Bring down your x, bring down your symbol, and what's 2 plus 7? 9. Now, I'm not going to write the other way for this one, but please know that 9, if x is less than or equal to 9, then that means 9 is greater than or equal to x, in case you don't see this answer in a multiple choice. Now, open or closed? Good, closed. And which way am I going to shade for less than? Good, to the left. So we're going to shade to the left. Okay, that concludes our notes on solving addition and subtraction inequalities. I hope you have a great day.